Okay, hello people. So this is our tool, it's called XRDP, and its main focus is on exploiting unauthenticated X11 sessions. So my name is Thomas, this is my colleague Darryn. We both work at SensePost as security analysts. And just a little bit about myself. So before I was doing the security stuff, I was a civil engineer. One day I was sitting in a meeting, looking around me, seeing all these old people, and I decided, well, that's not me. I want to be a rock star, so then I joined SensePost. Okay, so Darryn,
Hi everyone. I joined SensePost straight out of varsity. I studied computer science. I was originally planning to become a coder, but then I found security and it's so much more interesting. So I joined SensePost as well.
okay, cool. So XRDP, how did this start? So in the beginning of this year, we did SensePost training. About after 3 or 4 months, we got the time to do some research. Since we were both new to the field, we didn't really know what to do. So we asked the analyst some ideas, and the one guy, Dane, is the master of Autodane. Dane, make some noise. You didn't hear anything? Okay, so Dane told us he had this problem on assessments. Okay, basically, he got this vulnerability, and he didn't really feel that exploiting this manually was really working for him. So we decided to take on this problem. We were really excited about this, so we got started. So the first thing, if you might know what X is, but for those who don't, I'll simply give you a short description. Basically, if you are using a Unix or Linux type of system, then you are making use of X. So X is currently in the 11th version, so it's called X11. Mainly, you might know it by that name. And basically, it just plays a central role in displaying graphics on your screen. It originated from MIT, where back in the days, computers were really expensive, so they had this one main computer, and they needed a way for students just to connect to this computer and just share the resources. For instance, if they want to write a report, they can connect to this machine, have like a text editor or whatever display on their screen, and they could do their work. Okay, so looking at the basic architecture, there on the top left, you can see there's a keyboard and mouse, so that's basically your inputs. And the top right, that's a screen, that's where X will display the windows. And here, if you're on the top of the dotted line, that's basically your local machine. If you go below the dotted line, that can be some remote client. Okay, so X is basically a mediator between the user and clients, for example, a browser on your machine, maybe XTerm on a remote machine, anything like that. Okay, so you can imagine when there's lots of users using one resource, authentication must play a role somewhere. Okay, so we can imagine we have our remote server there. For the resources on, the first method of authentication is just by host. So the administrator, he can type in a command, he says xhost plus and give it an IP. So if you connect from that IP, you can authenticate. Okay, the next method is a cookie. MIT generated a MIT cookie. If your computer or terminal, wherever you sit, can prove that you have knowledge of this cookie, then you can authenticate as well. Last method, a little bit more difficult. This is where the server and the user both need to put their trust in a third-party machine through something like Kerberos. That's just another authentication method. Okay, so for one other method you can connect with, it's also authenticated, is simply through SSH. So it will update now. Okay, so what you do, you can just type SSH, include the -X option, the target machine. When you're connected, you can type XTerm, and then you can see your little terminal that will actually pop up on your local machine. Okay, so that's all good and fine. Everything is secure. Looking at an unauthenticated session, like one of the there's quite a few ways to mess this up. One of the ways is where the administrator allows TCP traffic on port 6000. Also, you can maybe mistype something, or if he is like just not in for struggling with authentication, you can run xhost plus. So any host on that network can simply just connect to that server. Okay, so the main problem here, or the what we have now, is an unauthenticated session. We are hackers. What do we love most? Okay, second most. We love shells. Okay. So our aim for this was we needed some either reverse shell, maybe a graphical shell, anything like that. Okay. So just one more thing on this unauthenticated session. You can export or export display, run that command, and that IP will typically be the IP of the remote server. And at the end, you can just type your command. Okay, so we have our remote server. We want to exploit it. What do we do? Okay, so this process is not just straightforward. There's a lot of different tools you can use. Every tool just give you some output. You have to chain that into another tool, and you go forth like that. There's no like fluency throughout the process, so it's really frustrating. Okay, so the first tool we looked at was xwininfo. That you just target display or window on the remote machine, and it displays some information. So looking at the command, so it's just xwatchwin. The screen will update now. Dash root simply says that you want to look at the root window. That will typically be exactly what the user on the remote machine will see. So display, that just says you're targeting display 10.2.10, whatever is running on there. Okay, so another important piece of information is the window ID. You need that for some of the other tools. Okay, so like we had some information about a remote window. We needed we needed to see what's on that machine. Can we get any output, anything like that? So the first tool we came across was XWD. It stands for X window dump. So you can run the command. It's xwd -display. That's a remote display. You're targeting the root window again, and you put that out to some file. Now you can't just read this file. You need to convert it into, say, for example, a JPEG, and then you can see what's going on. So this process is not very like this. It's very kind of blocky. You do one thing at a time. So we did some more research, and we came across xwatchwin. So this is a little GIF. This is typically what you'll see when looking at xwatchwin. So you can see what's happening on that server. It updates as quickly as possible. It's basically a bunch of screenshots that gets taken. And there is where you'll include your window ID. So at this point in time, you can see what's happening on the remote machine. You can just see what the user is doing. And we want to take this further, either just a reverse shell, like a reverse shell, or some graphical shell, since we really do love shells as hackers. Okay, and the last thing we looked at was xdotool. So what this enabled us to do is you can send some commands. You can, for example, open a terminal, you can open a file browser, but this is not, it looks easier than it is, because if you, say for instance, you export display and you run your xdotool, if you, after that, type something like XTerm in your terminal, then your terminal will actually be displayed on the remote machine. So that's rule one of hacking, like never hack yourself. That's just stupid. Okay, so in the second command, you can, for instance, send a mouse movement. But say you open this second, then you need to find a way to select your first screen, type stuff. If you want to just type like echo hello world or whatever, then it's got to be like a character space, character space, character space. So it makes the whole process really tedious. So basically, we were looking at some form to like get a graphical shell, remote shell, something very easy to use and that's not frustrating. Okay, so I'll give over to Darryn, and he'll tell you more about our implementation.
Cool. So we know what tools are available. And so what we need to do is take those tools and wrap them up in a nice bow so that they all work together and give us something awesome. So what we did was we decided to write a Python script, and we started off by running xwininfo using Python, grabbing the window ID, and passing that to xwatchwin, creating the screen, that updating GIF that you saw earlier. But now we had the output, so now we needed to figure out how to take input from the user and send it to the remote machine. We did some research, and we'd had to brainstorm a bit, like how are we going to do this? And we finally thought of just using a transparent overlay. So creating another window that's completely transparent, allowing you to click and with like text inputs and buttons and making it all look pretty. And so we looked online, how can we do this? We found PyGTK, and we decided to use that. The main reason for that, though, was with xwininfo, xwatchwin, and xdotool, there's already a lot of dependencies to this tool. So PyGTK ships with Python. So we didn't want, so that simplifies the installation process and whatnot. But in hindsight, that was a terrible idea. PyGTK is horrible, never use it. Like getting the buttons and, it was just, making it transparent took us ages. It was horrible. But we eventually got it to work. And then PyGTK allows takes the user inputs, and then you use xdotool to send those inputs to the remote machine. Obviously doing some processing, like taking a sentence and splitting it up into characters and whatnot. But once we had the tool, we decided we needed a fast and easy way to find a vulnerable host that would be fun to hack. So we created an Nmap script using the Nmap scripting engine, obviously, and there already exists the X11 access script that ships default with Nmap. But all that does is it checks whether the host is vulnerable to unauthenticated X11, which tells you, okay, it's vulnerable, but it doesn't give you a good enough idea of whether it's worth even looking at. And if you come across an internal network or something and every box is vulnerable, which one do you go for? So we realized that there were four main options. Option one, the box isn't vulnerable. Either the port is closed, the port is open, nothing is running, or it's authenticated. It's not very interesting or important. The second option is there's no active display. So the box is running X11, it's unauthenticated, but it doesn't respond to any of the X commands. We only actually found out about this after writing the tool and writing the script and using the script. When the script would keep failing and we were like, what's going on? So we run xwininfo against that box and it just bombs. But according to the output from the auth check, it's unauthenticated. We did some research into this, and we still have no idea why that happens. So that's some further work for us later. The third option is it's vulnerable, but there's no desktop environment. There's no desktop environment. So this happens generally when you run an X server, but without an operating system or anything like that. When you get a screenshot back, it's literally just a black a black image with the default resolution. So that's not very interesting either. And the final option is jackpot. You find a vulnerable box. That's the one you're looking for. What the script actually generates a screenshot and saves it to your directory. So you can, once you've run the script, you can just look at all the pictures, and the pictures are named nicely with IP addresses and whatnot. So you can see, oh no, this one sucks, this one sucks, this one sucks, that one. Let's go for that one. Once we created the script, it was time to take it for a test drive.
Okay, so as you can see, this is South Africa. Now imagine that you are the two interns, or just finished the training. You have this opportunity to write a nice script. Do you think this will be your main target? Well, this was not our main target, but we just started here. We thought we were gonna take over, probably the whole internet with our new tool. Okay. So we got some IPs from our scanning team, and these are the results. So just in South Africa, we scanned about 27 million IPs. We did that with mass scan, since we were just checking for port 6000 or X11 ports, and then after that we ran it through our Nmap script. Okay, so looking at the whole of South Africa, we found 4 vulnerable hosts. Now, not vulnerable like in every case you could see a desktop. We could see only one desktop. Okay, so this was really pretty disappointing. So we scanned the whole of South Africa, found one desktop environment, and we just thought that was really just lame. So we asked internally, did people see any of these X11 vulnerabilities on internals? And they confirmed it. They said they are quite not that common, but they do see them on internals. So this whole effort was not in vain. Okay, so the conclusion is that our scanning stopped right there. We did not scan the whole internet or whatever, but that's okay. So this picture will always remind us about this whole exercise. This is the one guy in South Africa that was vulnerable. Okay, so Darryn will quickly show you a demo of our tool, and I'll try to speak you through it, or he'll speak you through it as he goes along.
So I'm going to have to talk very loud, or I'll just talk very loud, don't worry. So I'm currently on a private network, and I know that there's a vulnerable host. So the first thing you're going to have to do is find it. I'm going to run an Nmap scan. Let me do that. Is that big enough for everyone? Cool. First, let me get the subnet I'm on, because I don't remember this IP off by heart. I'm going to Nmap scan my current network, looking for ports 6000. I'm going to make sure I'm only finding open ports, and just to be double sure, I'm going to use the default X11 script. What did I type in? Good one. Now we scan, and we find a vulnerable box. We get its IP, this is very difficult to do. And we scan just that IP. With our custom script, and it produces a screenshot and saves it to my temp drive, because I didn't provide it with this is a little to-do for later. We want to change it so that it's saves to the current working directory. But you can also supply it with the directory you're choosing. If you check out the screenshots, the screensaver has kicked in. That's great. Let me just okay. Let's try that again quickly. And you get a screenshot of the display. Once you have this, you go, well, that's vulnerable. So now we're going to run our tool, providing it with the IP address. I'm pretty sure this is still in my buffer. And the display. This is generally the port that it's running on. So this is 0, so port 6000. You run that, and it opens the tool on my other screen. This is very difficult considering the... I'm going to make my life a little easier for you guys, if you don't mind. Just going to change the settings so that it becomes one. That's better. There we go. So now we've got a graphical shell, basically. It's a little, it's as close to remote desktop as you can. Obviously you can see there's a text input box at the bottom, some buttons, so it doesn't auto-capture your keyboard, but it still allows you to do things like this. I can hit the Control-Alt buttons to toggle them on, type T, hit Enter. Since it's Ubuntu, it will eventually, when xwatchwin updates, open a shell. I can then type, who am I? Enter, when it updates, and then if I hit enter again, it sends the enter key, runs the command, and you get output. It also allows for mouse inputs. It doesn't do mouse tracking, however, but wherever you click, that's where it sends the click command. So I click the X, it goes away, click the menu. Eventually, it's a bit slow, but it's better than dealing with all of those multiple tools. Giving you a shell again. One of the other features we added in the bottom right corner, you can see, if I open a shell on my box, set up a netcat listener, opening port 4, I open my cheat sheet, I get my IP address. Put that in, I type the IP address, the port number, and I hit the R shell button. If you're getting annoyed with the lagginess and all of that stuff, what this will do is it will open a shell on your own machine, run what we call bash magic, spawning a reverse shell to your open port, and then minimizing the shell to try and hide the evidence. And little. If the user's an idiot, they'll not see the terminal. But if they set it up like this, they're probably an idiot. There you go. There's a reverse shell. If you run who am I? I'm free. And just to prove that this isn't the actual machine, I just magically, I got the virtual box behind some sort of overlay. There's the virtual box. and that's the terminal inside the watch. And you can see this is cutting through the overlay right there. And one of the happiest moments of this tool for me, originally when you clicked the exit button on the tool, xwatchwin would stay, and it would, when you click exit on that, it would bomb out and throw out some errors and whatnot. I got it. It was so messy. It was so great. So yeah, that's the tool. And then there's the GitHub. And to sum it all up, we took what was a tedious, horrible task. And every time you wanted to do that, you'd have to search long and hard to figure out how to use all of those tools, because xdotool for the life of me was irritating. And got a graphic shell out. Any questions? No questions?
How long did it take?
In total, about 2 to 3 days to code it all, and then on top of that, coding here and there over like a month to make it pretty and make it add some features. But the main bulk of it was 2 or 3 days. The first day figuring out. At that point, we were new to hacking, and I had some knowledge on X, so the first day was just figuring out what X was and how to use it and all that stuff. And then the Python came quite simple because it's Python. I mean, that's what it's there for. Any other questions? Comments?
What's the bandwidth usage of running X? It doesn't really use compression, does it?
I'm not as far as I'm aware, but we haven't actually done any benchmarks, so I can't give you a correct answer to that. But the screenshots, if you take a screen dump, it's usually not very large. So the xwatchwin shouldn't be using that much. Any other questions?
Just remind me why isn't a way, given that level of access, that you use export display? Do you also?
So you can't export the remote display to your machine. So you won't be able to run, for example, XTerm on the remote display and have the terminal appear on your box. The only way to do that would be through SSH or the proper means. But if they make themselves vulnerable like this, it's generally, the vulnerable box is generally the admin box trying to get connections from other machines. So they're trying to run XTerm on another box, and the terminal appears on their machine. So they made themselves vulnerable so that the terminal can come to them. It's taken us a long time, and we still get confused about it often. Which way the communication is happening.
So
But,
it's the X server that you're exploiting.
Yeah, so when we do export display, we're exporting the remote display. And then we run xdotool, and that sends keyboard inputs to the remote display. And if you export the remote display in the terminal and you run gedit will run on your machine but display on the remote machine.
So that box that you hit, it could be X server running on the same box, or theoretically it could be an X server running on a separate machine to what's being displayed.
Yes. And one machine can run multiple X servers on. You can run X servers within X servers. It gets complicated. But in the simplest scenario, this is generally what we find. Although there is one caveat to our tool, and that is that we still I've tried to create a lab for this, but we've come across vulnerable Windows machines, a Windows box running X server unauthenticated. And I have no idea how they got that in the first place, making themselves vulnerable using a Unix-based window management thing.
Yeah. For reflection X, something like that, but exporting a X display from a Unix server up there with those box.
But I found I did find a couple of tools, but one of the tools that I found was a paid for one. And obviously, couldn't get my hands on that. But this tool doesn't work against Windows boxes. So if you come across a vulnerable Windows box, this tool, all the default tools like XWD, xdotool, those do work. The xwatchwin bombs. So that's another tutorial for later, as Chris would say, which is to probably manually do xwatchwin within our code instead of relying on xwatchwin, which seems like a lot of work, which we haven't gotten to yet. Any other questions?